Hello all and welcome to this video where we're going to look at the mean and median for continuous random variables or continuous probability distribution functions. Let's jump straight in and we'll get started with the mean. So the mean, just like when we looked at discrete random variables, can also be called the expected value. If we carried it out 1,000 times, what's the average value? Or what value would we expect to happen most often? We can write it either as the expected value or as the mean or the average. Just like with the discrete random variables, the expected value is just the value of x multiplied by f of x, and in this case, because we're finding probabilities of a continuous random variable, we have to do that over the spread of all values. So if we think back to, just as a reminder, when we had discrete random variables, we had our value of x and our p of x, and this might have been 1, 2, 3, 0.2, 0.4, 0.4, and we multiplied each x by its probability, multiplied by its each probability, multiplied by probability. We got all those together. That was our expected value. We're doing the same here. We're multiplying each value by its probability and integrating over all the possible values. So summing them all up effectively. Oh, sorry, a little bit different to summing, but we're doing the integration because we're finding the areas, because it's technically f of x isn't the probability, it's the area under f of x, then multiplied by each value. So that's what we're doing. So it's exactly the same. It's x by f of x and just an integral from the left bound to the right bound, which could always be written as negative infinity to positive infinity, but a lot of our problems will have a restricted domain that just simplifies it down. So let's jump straight into it. Find the expected value of the random variable x, which has a probability distribution function stated here. 1 minus x on 2 for 0 to 2, and then outside that it's just 0. So again, we've got some function between 0 and 2, whatever the curve, that's a linear function. It's like that. Okay, and we're going from between 0 and 2. And that is f of x, and anywhere else, we're saying that it is 0. So the expected value e of x, capital X, is equal to the integral between negative infinity to infinity of f of x. Oh, I missed out a bit. I forgot the x times by f of x dx. Okay, so in our case, we don't have to go from negative infinity to positive infinity because we've got our bounds. So we're just going to go from 0 to 2. X times by, and we have to write in all of f of x dx. So we can now simplify that into polynomial form. So we're going to expand the brackets, so we're going to end up with x minus x squared on 2 dx. And now that we've got a polynomial, it's just a straightforward integration. So that's going to be x squared on 2, add 1 to the power, x cubed on, divide by the 3 times the 2 already had. I'm just going to straight away just simplify that to 6. Substituting 2 to 0. And now we just do our substitution. So we've got 2 squared on 2 minus 2 cubed on 6, all take away 0 squared on 2, take away 0 cubed on 6. That's going to be 4 on 2, take away 9, not 9, 8 on 6. Minus 0, 2, take away, let's just actually make it common denominators to make life easier. Times by 3, that's 12 on 6, take away 8 on 6. And 0, we're going to get 4 on 6, which is 2/3. So the expected value or the average is going to be 2/3, which if that's 1, 2/3 is there. Okay, so in our case, our most expected value, most likely value is 2/3, which will be the averaging of all those areas underneath. We can apply our same trick that we did in discrete variables, that if we're not wanting to find not the expected value of x, but we're maybe asked to find the expected value of x squared, whatever we're asked to find, we just put in front. Okay, we're multiplying by f of x. Okay, so if we're finding x squared, we put x squared in front instead. If we're finding the expected value of x squared minus 3, we're going to put x squared minus 3 all times by f of x. Now that's going to be a bit of a pain, take a bit of expansion, but that's all it is. We don't really worry about a shortcut in where we talked about what happens if this is linear, how we can find the expected value first and then run it through this little function. Because for continuous, we're not having to do those repetitive actions of multiply, 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 yada, yada, yada. It's just doing the single integration. So it doesn't matter if it's linear, non-linear, we just stick it in front of the f of x, multiply them, the two expressions together, and then do our integration. And here's a full worked example for you to have a quick look at. So let's jump in again, continuing to use our function that we have. So the expected value of x squared is going to be equal to the integral between. I'm going to shortcut a few steps. I'm not going to worry about breaking down this change here. Writing it first with negative and positive infinity. Let's just jump straight into, we know we're restricted to 0 to 2. We want to find x squared, so we're going to put x squared times by our f of x, which is 1 minus x on 2, equals 0 to x squared minus x cubed on 2, which will be equal to x cubed on 3, take away x to the 4 on 8, between 0 and 2 is going to be equal to 2 to the 3 on 3, take away 2 to the 4 on 8, take away, substituting in 0 into all of that is going to be 0. So we're going to get 8 on 3, take away 2 to the 4, 2 from 8, 16 on 8 is equal to, 16 on 8 is just 2, 8 on 3 is 2 and 2/3, so we get 2 and 2/3, take away 2, which is just 2/3. Which is a bit of a coincidence for this one, that we're getting the exact same answer as the previous expected value, but that's only a coincidence. It doesn't always hold true. Now, expected value of e to the x. Now, that means we have to find the integral of 0 to 2 e to the x, f of x, which is going to be integral 0 to e to the x times by 1 minus x on 2, which if we try to simplify is going to become e to the x minus x e to the x on 2. And the e to x we can integrate, but the x multiplied by e to the x, right there we've got a product of x and e to the x. We don't have a rule for integrating products, so this would be a CAS active question. I just want to, I've got something else I want to show you in a minute to integrate, so I don't want to take that off the CAS, but just put that in your CAS and get your answer. So it'll be whatever it is. That's as far as we'd go by hand. We could just integrate at this step as well. Rightio, percentiles. Okay, so percentiles are really useful. They're the x value, or if we look at our function, okay, we might, in this case, we want to know what value, which value here, p, does 75%. Okay, that's what this is showing from the lowest bound up to P. Is we want it to equal 75, or 0.75, which is 75%, or the area is 0.75. But the percentile is, well, what value does this occur? Is this like 2.3? Is it 75% of the people are under 2.3? Is 75% under? Could this be 8.7? We don't know, but we can use this sort of situation and solve this for P to find the percentile amount. We can choose any percentile. A lot of the time we care about either the 50% mark, because that's the median, that's the exact middle person. We could split it, and this is a symmetrical one, but we could find at what point is P so that we get 0.75, 0.75. So that's the median, not the mean. We could find 0.95 because we care about 95th percentile a lot of times. Or we could do 60%, make it equal to 0.6. But we can make this percentile equal to whatever we want. And we can do the top 50% or we can do the bottom just by flipping these two around, depending which sort of zone we want. So let's jump straight into an example. The reaction time of a group of people is a random variable x seconds with a probability distribution function as given by that. Okay. Find the value of A such that 80% of the group would take less than A seconds. So we want to know, again, we sketch whatever this graph looks like. Okay. It's clearly greater than 0 and does actually go up to positive infinity. We want to find what point here what point A occurs so that there is 80% or 0.8 area. So we're going to let the integral between 0 and we're going up to some point A, that's where we want to go to, of f of x, and we need to multiply this by x because, no, we don't. We're not doing expected value. Integral of 5 on 2 e to the negative x, and we want 80th percentile, so that's going to be 0.8, and I've left my dx out of there. So we can let 5 on 2, we can bring that out the front if we want to, just to make our life a little easier. Now we find an integral of e to the negative x, dx equals 0.8. Where to from here? We need to do the integral of e to the negative x. Integral of e to the ax, if you check your formula sheet, and I need to quickly remember what that is. So I'm just going to put that next in there so I can do this. Integral of e negative x dx is negative e to the x. Yes, the integral of e to the ax, in this case our a is -1, is just a e to the negative ax. Or is it 1 on? I think it's 1 on. But either way, we get 5 on 2 negative e to the negative x between 0 and a needs to equal to 0.8. Let's get rid of that fraction first. We're going to multiply it by 2 over to the other side and divide by 5. So we're going to get negative e to the negative x. 0 to a is equal to 0.8. And that's 0.8 is the same as 4/5. So I'm going to times that by 2 and then divide by 5. So we get 8 on 25. That's bringing this over by multiplying by 2 first and then dividing by 5. Now we do our substitution. So we get negative e to the negative a, take away negative e to the negative 0 is equal to 8 on 25. Come over here and let's negative e to the negative a, take away now e, anything to the power of 0, even if it's negative 0, that's going to be 1, take away, so that's going to end up all in here. That's 1 with a negative and negative, that becomes plus 1 is equal to 8 on 25. So we get negative e to the negative a is equal to, take the 1 away, that is going to be negative 17 on 25. So positive e to the negative a is 17 on 25. Take the log of base e of both sides. We end up with negative a is equal to log to the base e of 17 on 25. So a is equal to negative log to the base e of 17 on 25. And we could put our calculator in to find what that value is as a decimal. Let's actually do that quickly. We want negative log to the base e, which is log natural of 17 divided by 25. Okay, I want decimal. Let's redo that. 0.38. So a happens to be 0.38. Keeps going, but 0.38 seconds. So the reaction time to interpret what this actually means, find the value of a such that 80% of the group take less than 8 seconds. 80% of the people studied in this study, or whatever it is, had a reaction time of less than 0.38 seconds, which is pretty accurate to real life, I think, because I think the average reaction time is about 0.2. And if we want to find out what the average was, if we were given in this equation, we would find what the expected value is using one of these methods back here. Sometimes, in this case, this was a lot of work. Okay, we can do it in CAS. Okay, up here, I'm going to delete that X out of there. And we just have to be really careful, and this is why I had this not quite filled out at the moment. There's one issue with the Casio class pads where you build everything right. We're going to solve this. What we've got on the slide. We're solving this situation. We want to find the M value for a 0.5 percentile. We're solving for M, solve for M, and we can type it all in, and it looks fine. So I've got this equation 2 times by 1 minus x dx, okay, and that needs to be equal to 0.5, and in this case I'm solving for m. Okay, and I'm going to run it, and I get incorrect number of arguments. And you can look at this thing, and I'm telling you right now, it's actually, there's no wrong brackets. We are solving for m. I've put that in the right spot. I've got the comma in the right spot. All my brackets are fine. What the error is, and it's really, really annoying, okay, on a Casio class pad, is we have to put in this dx, and it's not pre-filled. It would be so much better if this was pre-filled. But when we're doing the integral, we've got to put this dx, and what I want you to notice is there's the box where we put the x in, and then if I go across, the line actually gets bigger. So if I now put x in, what I did wrong before is I pressed the equal sign straight away, which makes sense. I've got that integral, I want it to equal to 0.5. What's actually happened is I've put x and the equal sign inside this box. I'm trying to find the derivative of, or trying to integrate, not for the variable x, but x equaling blah, 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 everything else I type. So what you need to do is go dx, use the right x, and then you have to press across. It's so tedious, so annoying, but you have to do it. Okay, you can't be in the x of stating what variable we're integrating with regards to. You have to press across, then put equals 0.5, solving for m, close our brackets, and now you'll see that works. Okay. And we get m is equal to 0.29 or m equals 1.7. You then just need to look at terms of your function. In this case, that function was that linear one before, and once we get past 1, or it's similar to the linear one we did before, but as we get past 1, the line goes under 0, so that's clearly impossible. We'd have to exclude that in our domain, so the only allowable value for m is 0.293. So the 50th percentile in this case, or the average value is 0.292, blah, 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 blah. But I want to point that out with the CAS. It comes up every year. Kids get stuck with it in the stack. You get stuck with it in an exam. In an exam, high pressure, you're freaking out. What it is when you're trying to solve that integral and you get incorrect number of arguments, you've just got to go back in, delete everything out after the x. Okay. That's inside when the line's little, that's inside where we fill in the x box. Okay. You have to press across so the line becomes large, then do your equals, and then you can type the rest of it. I'm going to leave the video there for now. You can use your CAS, okay, to find the median value. So all you're doing, just to be clear, is we are solving 0 to a of 5 onto e to the negative x. We're going to let that because we want the median. That's the 50th percentile, so it's 0.5. And you're going to solve that on your CAS for a. So you pretty much, on an exam or SAC, you would say let this, and then whatever your CAS spits out as the answer, you'd write a equals. And that's it, you're done. That's the end of the video. So that's a look at mean and median for the continuous random variable. Again, it's using lots of integration because we've got a function, an actual line that we're finding the area under to do all of this. The next video, we're going to go on and look at measures of spread, so our standard deviations and all of that stuff again. Thank you for watching. If you have any questions, let me know.